Okay, this is our Calculus 1 in-class differentiation practice, and this is our one and only problem where we're going to practice using implicit differentiation. And it's kind of a cool problem, and I did graph this on my TI Inspire, and I wanted to show you where there is some limitations on what you can find because it's implicit. So recall that implicit functions have our x's and y's mixed. And I know there's different ways to teach this, but I'm going to tell you that if you do it the way I show you, when we start doing related rates, you'll see that it's much easier this way. So it says find all the points on the graph where the slope of the tangent line is -1. So I'm just kind of copying over my function. And as soon as I said slope, I know I need to do my first derivative. As I look at this, I see that I have a product rule going on here. So there's my f and g of my function. And I also have a product rule going on here. So before I do the derivative, I'm going to set up my f and g's. So my first f is x squared. My f prime is going to be 2x. And don't forget your derivative with respect to x. Your g is y squared. Your g prime is going to be 2y, the derivative with respect to y. Like I said, there's different ways to learn this. This is my favorite and it works very well. The second one is I have x times y. So my first f is x. My f prime is going to be 1 dx. So we're just going to put dx. My g is y. My g prime is, the derivative of y is 1 and it's with respect to y. So we're just going to write dy. So I kind of got it all set up here to do the derivative. Okay. So let's do the first one. I got f prime g, so I've got 2x y squared dx. So I want to show you that I'm taking this, the 2x and the y squared. At the end, I'm putting the derivative with respect to x, plus f g prime. I'm doing the same thing, so it's going to be 2x squared y dy. Okay, plus now I'm going to do the other quotient rule, product rule. So I got f prime g, so I've got y dx plus x dy. You kind of get used to the x times y one. It's kind of fun to do. And then I did the derivative of 2, which is 0. All right, so I've gone through and I've done all the derivative. The second step I want you to do is go through, because we want it, we're solving for dy dx is what our slope is. So we're going to go through it and divide through by dx because that's what I'm looking for, the derivative of y with respect to x. So I'm going to go through and divide through by dx. When I do, I can say, thanks for playing, that one's gone, and thanks for playing, that one's gone. I do know there's methods where people will just use y prime and they don't do the x one because I know that, and that's fine. But I found this method to work the best. Okay. Now I'm going to basically keep the terms with the dy dx in it. So I'm going to use this one right here. I'm going to keep this on this one side, move the 2x squared y, the xy squared and the y over on the other side. So what I'm going to do is to save a little steps, I'm going to factor out the dy dx right off the bat because that's what I'm solving for. So that leaves a 2x squared y here and plus x here. On the other side, I moved them both over. So I have a negative 2xy squared because I subtracted. And then the other one here turns to a minus y. So I've got it where I've got the dy dx isolated. It's multiplied by this. So I actually divide by this glop because it's hooked by multiplication. So I have the derivative dy dx equals negative 2xy squared minus y all over 2x squared y plus x. Okay, so what I always like to try to do is see if I can factor to simplify this. So in the numerator, I'm going to actually factor out, because there's y's in common, but I'm going to factor out a negative y and see what I get. When I do that, I get a 2xy left, and it's a plus 1. In the denominator, I'm going to factor out an x, because both terms have that. So I have 2xy plus 1. And now you see why I did that. I can say thanks for playing. So I do know my derivative is negative y over x, which is much simpler than what we saw here in blue. Okay, so to look back at the point of this question, it says find all the points on the curve where the slope of the tangent line's -1. Well, here is my derivative. So what I'm going to do is take that and I'm going to put it equal to -1 because slope is rate of change, and that's what we're going to do. So I'm going to put it equal to -1 to figure out what line that would be that would intersect our graph to find the points, because they want us to find the points where the slope is -1. So I'm just going to put this over 1 and cross multiply. So I have -x equals -y. So the line is y equals x. All right. Now you're like, how does that help me? All right. Well, it tells you that I can substitute x's for all the y's and vice versa. So that takes our original function, which is above where you can't see it, as x squared y squared plus xy equals 2. And wherever there's a y, I can plug an x, and then I'd have one variable to solve for that. So I have x squared times x squared plus x squared, because x times x is x squared. I'm going to bring over the 2, make it equal to 0. So now I have x to the 4th plus x squared minus 2 equals 0. And then I'm going to factor that to see if I can find my x terms. So I've got here x to the 4th. So that's x squared and x squared. This is 2, so I'm going to use 2 times 1. In the middle is positive, so it's going to be my larger numbers by the positive. Okay, and this is x squared. And then I'm going to factor this some more. So I have x squared plus 2 times x plus 1 times x minus 1 equals 0. So what I'm going to do is basically put each piece of this, so I'm making a huge T. And x squared here will never equal a -2, so thanks for playing, but that's not going to really help us find that. So I'm going to put x plus 1 equal to 0, so x is going to equal -1. X minus 1 equals 0, x equals 1. So I know the points are -1 something and 1 something, and since my y's equal x's, okay, then that means it must be -1, -1, and 1, 1. So that's the 2 points on my graph, that's my answer, where the slope is -1. Okay, so let's look at the graph. So I did graph this on my TI Inspire, and what you see that looks kind of like a star is my graph, and I had to use a relation plot. So I had to put it in because my x's and y's, and then I graphed the line y equals x, and as you can see, it does cross here at 1, 1 and at -1, 1. So that helps you, but you cannot do any other at least I haven't found out how to be able to do that, to find any more on that graph, because it won't allow you. When you try to find to find something like this, I want to analyze my graph of my dydx, it doesn't even let you do it. Oh, I can do this, but it's hard for me to get it exactly. So let's put it here. So that's negative, it's close to -1. I guess I can do that part. I didn't think I was going to be able to. So let me try that here. Let's do my dydx right here on this one, right here, and see if I get it. This one I got a little bit better. So I'm as close as I'm going to get to a -1 slope. So you can check that, I guess. I just couldn't do a tangent line. That's what I tried to do, was draw a tangent line. Well, let's see. Let me try it now on here. So I'm going to do geometry. I'm going to do points and lines. I'm going to do a tangent line. Yes, it does. I take that back. So I'm going to do it right. Whoops. Geometry, points and lines, and tangent line. And it's very close to that, but the slope is negative. So that, I hope this video helps, and that you can, I just enjoy doing implicit differentiation. I think it's a lot of fun, and this will help you when we do related rates later on.